will be discussing theoretical concept initially. About every concept, we do have certain theory, means certain points to understand and remember. So that I'll explain first. Later, we'll start with demos. We'll be working on a couple of examples or demo applications on each and every concept. It will be like this. So both making you to understand the concept theoretically and making you to memorize the important points about that particular concept, and then we'll be seeing the demos also hands-on. During the sessions, I will be typing almost all the applications, and I will be demonstrating to you. And when the programs are really complex and large programs, then I will demonstrate the existing application. It will be like that. And this is our way of learning further today onwards. And today we'll be trying to understand about what are microservices and the difference between microservices and SOA, and the principles of microservices architecture design when we are trying to develop a microservices architectured application. These things we try to understand, and later we'll be continue with the advantages and disadvantages and ecosystem that involves in the microservices architecture applications. Basically, what are microservices? When we say it is microservices, uh, we can think of microservices as an architectural style to build the system. Just like how do we have an architecture to build or to construct any construction, or to do any construction or any building, uh, we do have generally some architecture documents similar to that. To build our software systems, we do follow certain or we do use certain architectures, right? So when we are saying microservices, it is one architectural style to construct or to build our applications, business applications. That's why I'm demonstrating this architecture diagrams here to say that microservices is an architectural style. Is this architectural style a new architectural style? Basically, it is not a new architectural style. It is a old style which was existing or which was in practice, has been evolved as a new approach to develop the systems. So that's why what we can say, it is the old new thing, something like the old wine in the new bottle kind of thing. So what is that? The old thing that was existing in the industry or in practice before microservices is SOA, service oriented architecture. So what is service oriented architecture? Which is defining about developing the web services as per our business requirements, and make our system more loosely coupled system, or independent modules can be developed in our applications, legacy applications, and make a reuse of same components in several places in our application. So that was supported by SOA. But that SOA, that scope was what corresponding to one single application. Within the single application, how to create independent loosely coupled components, and how to make minimize the impact of one module changes in other modules. It was like that. But as business is growing in the current world, in the new business era, the business is growing drastically, and the requirements are also changing very rapidly. So to meet the a new era business world requirements, we need a new architectural style or a new approach to develop our applications. That's where SOA is not able to support all the new requirements. What are the new requirements or new world business requirements? Like a speed of delivery. Applications must be delivered as soon as possible. Mm. So here application means it doesn't mean that entire application release. Mm. Even every application may require to have new feature release as frequently as possible. If new features are not uh, added, then what happens? Application will be get outdated in market, and it may lose its existence in the market. Mm, that is what the new era business world requirements. And even business cannot wait for a longer times for the product to be developed and released. They should any even though we are starting with a very new project, business cannot wait for uh, a longer time, so that project can be completed, means built completely and released for it. For example, assume that you might be starting developing an application today, and if you estimate that applicate to complete that entire application, it may require 1 year of time, but business cannot wait for such a longer time. Hmm. Earlier in the beginning, in even before 2000s, it might be it was the case. In 90s or 80s, it was the case. Okay, business at that time, business was not matured like today, and that was not the requirement. But from 2000s and now even after 2010, it become very rapid in the business, right? Oh, so they cannot wait for a longer time. So the speed of delivery is not there, then they will lose their business. So not only our software product, even customer business also will lose the market. So one live examples what we can see. I think you might be knowing one some applications like on social platform like Orkut, Yahoo Messenger. You might be knowing, right? Orkut, you know, right? Whose product Orkut is? It's not a
Go
very startup product. It is Google product, right?
Google product. Yeah.
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 Yeah. But still, the giant is supporting that product. It has been vanished from market. Why? Because and even Orkut is not a small, not containing a small user base. It was also having millions of users, but still it has gone from the market. Why? Because not having faster delivery of new features. After Orkut only we got Facebook, right? Facebook is giving started to give new features day by day. Very frequently, new features releases were there, and all the users turned to Facebook. So that is one simple example. Say, if speed of delivery is not there, what happens? Even though the product is having a large user base and supported by a giant company, still it can lose its existence. Even in the similar way, Yahoo Messenger also. Yahoo Messenger also, one was the that was the only one option what we had to chat with our friends or buddies across the world. But what happened, as it is not providing new features constantly, it stagnate with only the limited features. What happened? Almost it's also gone from the market. So many others have introduced different charting applications through mobiles and all, where Yahoo did not update its messenger to support mobiles and all. So it's gone. It's lost its market and lost its existence in the market, like that. So what this and if you consider the e-commerce applications like Flipkart or Amazon or eBay, that would require to release a new feature uh, every day. Every day there might be several releases of different features which are being added to their application. That's why they are trending now. So such speed of delivery is not possible with classic SOA, where we are developing entire application as a monolith application and uh, maintaining it. So that's not possible with SOA. Yeah. Next, scalability. Scalability means based on the load, application should scale to serve the whatever amount of load that comes from our users, the software means application users. Initially, application might be expected to uh, get 100K requests per day, but over that time, as product is our application is popular or business is growing, it may require to uh, process a million requests per day. Then uh, it should be open for such scalability to scale up to such extent to process or to serve 1 million requests per day for its users. So if it is monolith, SOA based monolith architectured applications, then what happens? Uh, Clients cannot offer to set up the infrastructure uh, uh, to process 1 million requests per day from the day one itself, their product launch itself. Why? Because even they are expecting 100K millions per 100K requests per day, but even first 1 month or 2 months or maybe in 1 year, they may not reach 100K requests per day. They may be serving a 10,000 or means 10K or 20K request per day. So in that case, maintaining infrastructure with the capacity of serving 1 million requests per day is a waste of the money. There will be resources wastage, a huge wastage of resources, right? That will incur lots of millions of dollars cost for the clients, right? Uh, that is one major uh, drawback with legacy applications, monolith applications, which are based on in-house servers or on-premises servers. And even mm, sometimes what may happen, they might be expecting uh, 1 million requests per day, but in peak season, that might be uh, 10 millions requests per day to serve. See, for example, if we take e-commerce applications, uh, on peaks periods or on special sale periods, like Flipkart or Amazon. In India, Flipkart is doing like a big billion days sales, or Amazon is announcing like a Great India Festival kind of things, right? At that time, huge hit will be there on the application. So automatically, application has to expand from 1 million to 10 millions load, to scale up to serve 10 million requests per day. So how it should be done? So for the whenever the requests are growing such a large scale, people means physically we cannot get the uh, um, uh, new infrastructure set up onto the premises, and we cannot install and deploy all our application softwares and our application to serve 10 million requests per day. And how long that sale period goes for? Only 1 week, like that, right? So whenever it is going for only 1 week, um, for because of 1 week period peak load, we cannot set up a large infrastructure for whole the year, right? It is again uh, loss of the resources. And even if we are not setting up that load, means to serve that load, what happens? Business will be lost. Customers will lose the interest, that uh, the requests will be dropping off or failing whenever customers are placing the orders. If it is failing, then what happens? Okay, application is not working, let's move to another application. They look for alternative options. So what happens? Obviously, the final end customer business will be a getting impacted and losing the market. So it will be a huge loss for the clients. So scalability also is a very important for in today's new business world applications. It has to dynamically expand to scale up to serve the new high loads. And whenever load is done, means the sale period is completed, load will be shrinked, right? Reduced. So according to the reducing loads, again the resources should be shrink to previous standard mode. So how this should be managed, the scalability of the application resources. That also an important factor that is required for the new era business world applications, which is not uh, possible with SOA applications, monolith architecture based SOA based applications. It is not possible. And one more important requirement is there should be a way, or there should be doors. The doors should be open for uh, showing the innovation and experimental implementations of new technologies in our applications. So we cannot stick for same technology forever. We should update our application with the new uh, and experimental new softwares as the softwares are updating in the market, right? So, and even we should be allowed to implement any innovative uh, technologies in the applications. So then only application will get newer form and newer performance standards, all these things. So now, and another important point or feature that is required is uh, our application should be cloud ready, and it should be open for DevOps culture implementation. So application should be cloud ready means now to minimize the cost for the infrastructure cost, it is recommended to have all our applications to be deployed on cloud, not on the in-house servers, or not on the on-premise managed servers. It should be open for deploying onto cloud platforms like Azure Cloud or AWS Cloud or its own organizational internal cloud. So, with the cloud, what is the advantage? Well, because it is a distributed environment which could be distributed across the globe, and it can uh, give better performance and user experience for the end users. If it is a single managed on-premises server, then what happens? There would be response delays when clients are making or customers are making, means end users are making requests from different regions on the geographical regions, right? If it is cloud, we can set up the application to be we can make a application to be available from different geographical regions, so that when customers are making or means users are making the request based on their geographical region, the corresponding cloud instance will serve quickly and gives better user experience. So all our new era applications are required cloud deployment and not the on-premise server deployments. And a DevOps culture. DevOps culture means the release means build and release should be integration. Build release should be a continuous process with automated automation. It should not be user or manual task anymore to achieve frequent releases to achieve frequent releases of our application. If it is manual build, manual deployment, it takes a lot of time, and a man cannot a person cannot do um, several deployments in a day. We need to employ multiple, means client should employ multiple people to integrate and deploy the application every time when new features are coming. So if we are integrate and incorporate the DevOps culture, then DevOps practices, then what happens from developers, the software will be moved to operations as quickly as possible because of automation practices implemented in the system. So new applications should meet or should provide or support all these requirements in the current trends. That is why uh, we need a modernized version of SOA, which is nothing but our microservices architecture. This to cater all these requirements, we need a modernized version of SOA. The regular SOA does not work. Hmm, Yeah. Now let's compare the monolith applications and microservices applications. Here, comparison of monolith architecture and microservices architecture. So in monolith architecture, how the things are, and in microservices, how it will be reformed. We see. Whenever we are developing any software in earlier with the legacy systems, nowadays we can say legacy systems, monolith applications. That means what? Only single distribution will be there corresponding to our application, which we are delivering to the customer. So single distribution means it could be a single WAR file or EAR file, which would be required to deploy on the servers like a Tomcat or JBoss or WebLogic or WebSphere. And from the server, it would be uh, used by customers, means end users. So in that single build, uh, obviously, even though it is single build, we are not writing the code, uh, entire code as a single package. We will be dividing our code into different components in different perspectives. In business perspective, we will be organize and divide our code into different modules. We can say like module A, module B, module C, module D, like this. We might be dividing our application into different modules in business perspective, and corresponding to when coming to technical perspective, we'll be organize our code into different layers like a presentation layer, business logic layer, database layer, like this. Right, you might be seeing already, you might have seen these things, right? You might be aware of this. Our project is divided into different modules, or our project, we are working on presentation layer, business logic layer, like this, right? So this is what the typically the organizing of the code in monolith. So, but at the end of the day, what happens? All the modules code and all the layers code would be built together into a single distribution, a fat var or large var file or EAR file, enterprise archive or a web archive or jar file. But jars will be very rare case. Most of the cases var or EAR, which would require, which would be a huge file. The application would be a very big huge file, and uh, because of this single distribution build, if any changes required to be done in module A, that might have impact on all other modules. Lots, it may have lots of impact on the other modules. And if I want to do any change on database layer, that might show a lots of impact on other modules also, like presentation and business logic layers also, like this. It is so at the end of the day, what happens, system will become a tightly coupled system, which will require to uh, do so many changes for even a small requirement, and lots of regression testing would require, right? Regression testing is nothing but repetitively test the application again and again to ensure that everything is working fine. If I do a small change in module A, but it is not enough to test only the part which I have changed in module A. I have to test entire system to ensure that it is working fine, right? Otherwise, we cannot assure that application is going to work fine. So that is the problem with monolith applications. Even though code is organized into different modules and different layers, it will be at the end of the day, it will become a tightly coupled system, which would require, which would make it is harder to incorporate newer enhancements into the applications. Now, when it comes to microservices, then what happens? Application code will be divided into a small and individual components. Here we can say, instead of modules, see, if in monolith application, you can see here, you can label these are as different modules in the same system, same build: customer module, order module, accounting module, product module. But when it comes to microservices, each feature or each module in the monolith can be made as independent product. Instead of the module, you can develop it as a product, independent product, which is independent of other products. Uh, and each will be deployed independently on the servers and will run independently. Not like all modules together will be deployed on the server and run together. It will be deployed onto the server independently as independent applications, and it will run independently. So the changes that are made to one product, means in one module product will not affect other, or will not have much impact on other components. So like this, we can make the newer enhancements would require to be done on smaller components rather than whole system, rather than doing on whole systems. This flexibility we get with microservices architecture if we try to design and develop our application with microservices architecture. Application code has been organized into different independent smaller microservices, but at the end of the day, all these microservices should work together, right? They should cohesively provide a whole functionality for the end user. I cannot say that it is customer microservice I can provide, uh, means we are providing only customer related operations like registration of customer or login of customer only. At the end of the day, as the entire system holds as a single whole system, cohesive system, it should provide all the functionalities to the end user. Like a user should be able to register as a customer and should be able to place an order, or should be able to browse the products and see the product details and get the invoicing information, right? Everything should be provided from the single interface. So here, what is the requirement? Uh, when customer or end user is using the system, these individual microservices again required to uh, communicate with each other. These microservices are required to communicate with each other. So how do they communicate with each other, microservices? That's what I'm trying to say here in this slide. Microservices will communicate through APIs. Will communicate through APIs. Every microservice will expose an API. Through APIs, every microservice will communicate with other microservice. And every microservice code, again, you might be organizing into different layers. Every microservice code, like presentation layer, business logic layer, database layer. In some microservices, presentation layer would require the user interface. In some microservices, a presentation layer may not require. Only business logic layer and database layer may require. So you might be developer like this. Now, these two microservices, how do they communicate? Through APIs. One microservice, every microservice will be having certain resources or producing the resources, means functionalities. Those functionalities, produced functional resources, should be consumed by another microservice. But how this consumption happens from one microservice to other microservice? Through APIs. So what is an API? How do we create such API, and how do we expose that API to the external world? That will be understanding and implementing in our demos when we are working and discussing further concepts with Spring Boot. But as of now, you need to remember that how understand and remember that how microservices can communicate with each other through APIs. So this is how microservices will communicate with each other through APIs. By exposing the APIs, microservices will communicate with each other. Next, when we are designing a microservices architecture based application, we need to consider these points. Means several points we need to consider, but the important key points that we need to take into consideration are these 6 points or principles, we can say, are points to be taken into consideration while designing microservices architecture application, that are like modularity, autonomous, hiding implementation details, automation, stateless, and highly observable. So these 6 principles are key features we need to take into consideration when we are designing our microservices. Uh, and when we are implementing our microservices, all these points we need to consider, and we need to ensure all these points are satisfied or implemented. Now, what are these? Exactly, the modularity means in what perspectives we need to provide the modularity, and how do we need to have the modularity, and in what perspective autonomous means, and what is hiding implementation details. All these details, let's understand in clear